Alrighty, I'm going to make a review for this test, Unit 2. Which divisor of this polynomial results in the remainder of negative 171? So we're looking at these answers, which is a divisor that gets this remainder. So you're going to long divide it. Now that'll take you way longer, so it's better to use synthetic. So to use synthetic, what I'm going to do is I'm going to take the zeros of each of these factors. So the zero of what makes x minus 5 0 is 5. What makes x minus 2 0 2, and so forth. And so what I did is I do synthetic. My coefficients are 2, 4, 5, and 4. 2, 4, 5, and 4. I did the first problem, I took a 5, because that's a 0, and I did synthetic. And I do it for each problem until I find the one that has a remainder of negative 171. Now, how do you do synthetic? Let's do a little review of synthetic. So let's just look at the one that's correct right here. So again, I took the 0, for that would be negative 5. I took the coefficients, again, they're right there. And so what I do is I take down the first number, put a 2. I multiply negative 5 times 2, put it there, add down. I multiply negative 5 times negative 6, put it here, add down. I multiply negative 5 times 35, put it here, add down. This right here is your remainder. That's how synthetic works, and it's a lot quicker than doing long division. Alrighty, this problem, which is the following, is a factor of that polynomial. So these are your factors. It's a lot like the last question. Okay, to be a factor, you want a remainder of 0 when you divide. So I could take this and divide it from this and take each one, but long division takes longer, so I'm going to do synthetic again. So what makes this 0 is 3. What makes this 0? Negative 5, and so forth. So I'm doing synthetic, like last time, using these numbers, and I try to find a remainder of 0, because if it's a factor, it has a remainder of 0, nothing left over. So if you see right here, see our remainder of 0? I used 5 here, and just be aware, this is a cube, squared, a first power, and there's nothing in the numbers digit. So see how I put a 0 at the end? Be very careful of that. 3, negative 11, negative 20, and 0. People forget that. Anywho, what I do then is I just do synthetic, and I'm looking for one of these that has a remainder of 0, and that would be your answer. Again, synthetic really speeds up the process. All right, for this next problem, which polynomial function has zeros of these? Now, the process I'm doing here is one way. There is another way too. But if you know these are your zeros, don't you know your factor? If your 0 is negative 4, your factor is x plus 4. If your 0 is negative 3, your factor is x plus 3. If your 0 is 1, your factor is x minus 1. So this right here is factored form with these zeros. Now, so if I were to FOIL this out, I get this. If I were now to multiply these two with this box right here, all right, I get, oh, sorry, let me start over. This right here needs simplifying. I get to here. This right here gets simplified to here. So if I multiply these two, see right here, put the box, multiply it out, I get my answer, which is right there. That is one way to do the problem. You just simply change it to factored form and do a whole bunch of boxes and foiling, whatever you need to get it down to a polynomial. Now, another way would be to technically look one by one and do synthetic, which with each of these zeros until you find out which one of these all 4 zeros work for. That is completely another way. All right, so you could, again, I would test 1 first. So if you test 1 into these, now right away, basically, you could actually cross out this problem, because if there's 3 zeros, it can't be an x squared. But if you try 1 into here using synthetic, if it works, then you try negative 3. If that works, then you try negative 4. And you would find out it doesn't work for all of them. In the end, you would find this is the answer, because if you do synthetic with 1, negative 3, and negative 4, it would work for all of them using synthetic, meaning you'd have a remainder of 0. That's what I mean by working. So these 3 would have a remainder of 0 using synthetic, using this one. These 3 would have errors, meaning not all 3 of those zeros would work. Alrighty, for this problem, I'm going to see which of these 4 graphs could be this polynomial function in standard form. Well, what you do is you look at this front. That's a third degree, and the a value is positive. So if I know it's a third degree with a positive a value, I know it has that look. So I know it's going up on the right, and they go opposite directions. So right away I can cross out this one and this one. This one because it's not third degree, which is odd, and this right here is a third degree, but it's going down in the end. So it's one of these two. So now what do is I go back to my most basic way to graph, and that is plug in values. The easiest value to plug in, you can see down here, is 0. So if I take 0 and plug it into each spot, so I get 8. So what that means is I have a coordinate of 0, 8. So which of these two have a coordinate of 0, 8? It's right there. This one has a coordinate of 0, 8. So that's going to be my answer because this one does not have that coordinate. You could plug in even more numbers. It's just 0 is the easiest. And this is a good way to verify if you have two options after you look at the degree and the lead coefficient. Alrighty, so for this one, which is a graph of an odd degree function with a negative lead coefficient? So odd degree means that both sides are going to go opposite directions. So I could cross out these two because they're even. See how they go the same direction at the end? So we cross out those. Then a negative lead coefficient. Well, that means that the end is going to go down. And you see here, I see how the end is going down? That's why the lead coefficient is negative. Or here, see how the end is going up? So we know it's going to be this one because it's going down and the sides are going opposite directions. For this next question, there's actually lots of different ways to explain it. Let's do this. What is the relationship between factors, roots, zeros, and x-intercepts? Well, roots, zeros, and x-intercepts are really all the same thing. They're just different names for x-intercepts. So that's the most common, but these are your two most popular words for x-intercepts when it comes to polynomials. A factor, well, what is a factor? Well, when you plug a 0 into a factor, you get 0. Basically, factors look like this right here. That's what a factor looks like, where a 0 looks like this. So that's kind of important to see the difference. Now, the next question is, what does it mean if f of 5 equals 0? Well, what does that mean? Well, if f of 5 equals 0, means that 5 is a 0, because 5, when you plug in, gets 0 out. Otherwise, you can also say that if 5 is a 0, then x minus 5 is a factor. Because, remember, the factors are always kind of opposite of the zeros. Now, what does this one say? Well, this is saying that, right here, saying that 5 is not a 0. Because when you plug in 5, you do not get 0. Which also means that x minus 5 is not a factor. All right, another way you can also think of it is, when you see this, it's saying when you plug in 5, you get negative 3 out, meaning there's a coordinate 5, negative 3. This one also means there's a coordinate 5, 0, so you could say that too for that particular one. So let's describe the transformation of f of x equals x cubed that yields this. Well, x cubed is your most basic polynomial, cubic polynomial. Here we have an a value, an h value, and a k value changing this. So what does the a, the 2/3, do to it? What that does is it creates a vertical shrink of 2/3. Because if I multiply anything by 2/3, what you're doing is just shrinking its value. If you multiply by a 5, you're growing its value. But since it's less than 1, you're shrinking the outcome of it. So all the values of this graph are going to be shrunk by 2/3. Now, what is this number here? Well, this is your h and this is your k. Now, this one's always opposites. Okay, so that's a negative 2, and this is a negative 5. So this is your hk, a specific point. But what this is really saying is you're shifting negative 2, meaning left 2, and this is saying you're going up 5. So you see this? I'm horizontally shifting left 2, that's negative, and I'm vertically shifting down 5, because it's a negative 5. Remember, this one's always opposite. Now for this one, what degree polynomial is the following function? Well, what you do, if it's in factored form, is you just add the powers. So the 1 power there, 2 and 2. Remember, there's no power, it's a power of 1. So 1 plus 2 plus 2 is 5, 5th degree. So this is an odd degree polynomial. So for this particular problem, use this table to answer all these questions. You don't have to have the graph, but the graph helps. So first thing I did is I graphed it. I just took 1, 3, so I went over 1 up 3, 3, 1, so I went over 3 up 1, and so forth, and got all the red dots. And then I kind of try to draw a polynomial through it. Kind of an ugly polynomial, but that kind of would be my polynomial that I can possibly see through it. First question, on what interval is the function increasing? Increasing means that it's bigger than the previous value, or it's going uphill. So if you see right here, isn't this value to this value getting bigger? So that is where it's increasing. Now what's that interval? Well, the interval is from 5 to 2. So it's interval from 5 to 2, it's going up. There we go. So what interval are there likely zeros? Well, zeros would be right there, there, and there. Where does it cross the x-axis, or zeros? So what intervals would they be? Well, it would be between 3 and 5. Okay, the reason I chose intervals 3 to 5 is because I'm looking at the table. Now, you could have shrunk that down to say, oh, between 3 and 4. You could have said between 3 and 4. You could have said here, well, it hits right here at 6. You could have said between 5 and 7. I'm just using the intervals from the table. Here, you could have said between 8 and 9. Or you could say between 7 and 9, because 7 and 9 is what the table gives. But for my picture, if you look at my picture, you could say between 8 and 9. But it's best to use the table, because really all we know for sure is the table. So we don't actually know where the graph crosses. So for you to say between 3 and 4, you don't know. It could have done something weird and come over to here somehow and kind of come through there. Or here, it could have gone sharper and come down to here. You don't know for sure that it crossed between 8 and 9, just my picture does. So it's better really to use the intervals here from here. So we know it crosses between these two, and these two. Now you don't even have to look at the graph. You can just look at the table. For instance, if I have a 0, doesn't it have to be change signs? So every time you have a 0, it changes sign. So I know between 3 and 5 it changes signs, meaning positive and negative. I know between 5 and 7 it changes signs. And I know between 7 and 9 it changes signs. So you don't even need the graph. You could just look at the table to see when it changes signs. So what value of x is there likely a maximum? Well, maximum are hills. So the hill is right there, it looks like, so that'd be at 7. If I ask for a minimum, it'd be at 5. It's a valley. It's a little trough or a valley, bottom of a cup. Next one, at what average rate of change, what is the average rate of change on 1 to 5? So we look at 1, which is right there, see 1, and 5, which is right here. So what I do is I look and find the slope. Well, that looks like it went down 5 over 4. So down 5 over 4, reduce if you can. Now, what you do, you could also look at your table and see, how does this change? Well, from here to here, I dropped 5. From here to here, I gained 4. So I dropped 5 and gained 4. So you could look at the table from here to here and here to here, or you could look at the graph. I think the graph's a lot easier on this particular problem. Okay, next one. What does the function appear to be? Does the function appear to be odd or even? Well, it appears by how I can see it. Again, things could have turned around farther on, but for the picture I see, if I assume it keeps going up and I assume it keeps going down, if I assume that, okay, I can state this looks like it's going down, so I know it's down here, and this one looks like it's going up, so those are opposites, so I think it's odd. The last one, what is a possible equation? Well, if I use this graph that I came with, I can see it's going down in the end, so I know that's a negative. All right, I can see my zeros. I'm approximated from my picture. My 0 is about 3.5, so I do the opposite of 3.5. A 0 looks about 6, so I did the opposite of 6. My 0 looks about 8.5, so I did the opposite of 8.5. So that is one way of doing it. I just know it's negative, and these numbers are approximates. It just depends on where your graph crossed the x-axis. To write the function of the graph below in factored form, what you first do is look for the zeros. Okay, you could put y equals or f of x equals. And then if this is a negative 1, 0, the factor would be x plus 1. So I put that. If this is a 1 for 0, my factor for that would be the opposite, which is x minus 1. And if my 0 is 3, my factor for that would be x minus 3. Now, why do I have a squared on this one? Because I bounced. These are both throughs, so they have a single. And if it bounces, it's a even power. Now, if this was twisted through right here, you'd be putting a third on that probably. It's an odd number power, bigger than 1 if you twisted through here. But since they're straight throughs, you just put a 1 power or leave it off. You don't have to put a 1 power if it's a straight through. So for this one, I want to sketch this graph. Well, what I first got to do is I first got to look at this. That is a negative, so I know a is negative, so I know the end is going to go down on the right. And then I add the power, so 1 plus 3 plus 2 is 6, that's even. So if this is going down on the right, so will this, because it's even. I know they're both going to be going down. So if you see my graph, I'm going to go down on the end of both sides. Next, I know my 0 is 0, so I put a dot at 0. I know this as a 0 would be negative 4, so I put a dot at negative 4. And this would be 5 for a 0, so I put a dot at 5. Next, I start from each side. So I'm going to start from this side, and I'm going to be approaching, and this one says a cube, so it's going to be twisting through. So I know I started down here, so I go up and I do a twist through. All right, now I look at this one. I knew this one is a straight through, so I'm up here, so I go straight through down. All right, and my last one is this one right here, which is a squared, which is a bounce. So I know as I come back, I'm going to bounce off that, which makes sense because now I have both sides going down. All right, and I verify again. This one went straight through. This one right here was twisted, and this one right here is a bounce. So it looks like all the pieces are there. What is the remainder of this polynomial is divided by x minus 2? Now you could do long division, but it's easier to use synthetic. So the first thing you do is you think, what would be the 0 for this? It'd be 2, because 2 minus 2 is 0. Then you got to write this out, but be careful. There's no x squared, so you put a 0 there. So you have 2, 0, negative 1, and 5. Then we do synthetic, and we get a remainder of 19. So my answer is 19 because all it's asking for is the remainder. So find the product of this. Well, when you say product, you're saying multiply. And what that means when I have a cube, it means I have 3 of them. So we first multiply this out. I used FOIL. You could have used a box. So as I FOILed this out, I got this. See right here? When I FOIL this, I get this, which I reduced down to here. So I have this, and I still got to multiply this on. So I now have this piece times this piece. So now I use the box, put this on this side, put this on this side. I multiply these, multiply these, multiply those, and multiply those. These are like terms, so I combine those. And I always start with the highest power and work my way down. And that's the process. Just understand, if you have a cube, that means write 3 of them and do quite a bit more multiplication. Sorry for the work. All right, this is a little bit difficult question here. Given the function blank, write the function in factored form if 2 of its zeros are 0 and negative 3. So I'm saying 2 of the zeros of this are 0 and negative 3. So look over here. I'm writing a function. Actually, I just messed up. This f of x, so that should technically be f of x, not y. So I changed the front, which it's wrong, but it's going to be okay because usually those are interchangeable, but that should be f of x. Okay, so if I know my 0 is 0, so I know I could put an x here because x plus 0, or x. And then negative 3 is a 0, so that would be x plus 3. And I'm trying to find this piece. Now I know it because it doesn't work, but I'm trying to find this last 0, this last factor, and that's the question here. So how do I find that last factor? So what I do is I take 1 0 at a time, and I divide this 0 into that. Okay, so I take this 0, and I divide it using synthetic. So that's a 1, a 0x squared, a negative 9, and a 0 at the end. And when I do synthetic, I get this. See, I got no remainder. So what this right here is saying is that when you divide by x plus 0, you get negative 9. This is no x's, okay, and 1x squared. So this right here is wrong. I technically should have no x's. There's a mistake there, okay? So that'd be 0 x's minus 9. All right, so now I take this and I stick it right here because I'm now going to divide again with the negative 3. So I'm going to divide this by a negative 3. So I fixed it right here. See the 0, but that should have been a 0. Anyways, so I do synthetic again. I get no remainder. And this then would be a negative 3 and an x. So this right here is my last factor, which my last 0 would be 3, because 3 minus 3 is 0. So to find your last factor, what you do is you do synthetic division of each 0, and then you take the answer here and use that answer to divide out once again. So how many different 4th degree polynomials have negative 2, 6, and 1 as their only zeros? Well, there's negative 2, 1, and 6 are your only zeros. Now, couldn't this graph, see all the graphs I made there? Those are 3 different graphs I made that go through those dots. Okay, could I just keep making a whole bunch of different answers? Because it doesn't matter your A value. Whatever your A value is, changes these graphs like crazy. So there's really infinite amount of options for this problem. This next question, number 16. If x plus 6 is a factor of polynomial f of x, what do you know about f of x? Well, if x plus 6 is a factor, doesn't it mean that negative 6 is a 0? You could also say negative 6 is a root or an x-intercept. And you could also say that when you plug in negative 6 to the function, you would get a remainder of 0. Because if it's a factor, when you divide by x plus 6, you get 0. And when you divide by x plus 6, you can also use something called the remainder theorem and plug in negative 6 to see that your output should be 0. This problem, if you're going to subtract these two, just be careful to distribute the negative. Because if you don't distribute the negative before you combine all these terms, it'll fall apart. That negative distribution could mess you up pretty bad. So again, see that becomes a negative 2x squared cubed. This becomes a positive x squared. This becomes a negative, and that last one becomes a positive. Then I start with the highest power, which are these two. Then I go to the x squareds, which are these two. Then I do the x's, which is only 1 right here. And then I do the numbers. And there it is in standard form. Alrighty, so I'm going to take this and divide by 2x plus 3. You cannot use synthetic very easily with this one because your 0 is not very obvious. The zeros are more complicated here because it has a number in front. So this one forces long division. So to do this, you're taking this divided by this. So the first step is what times 2x gives us this, and that would be 3x squared. You multiply 3x squared times both these pieces, and then we subtract down. That cancels. Subtract down, you get 4x squared. Bring down the 10x. Now what times 2x gives you 4x squared? 2x. Multiply this times this, put it here. Multiply this times this, put it here. Subtract down, that's gone. Subtract these, you get 4x again. Bring down the 2. What times 2x gives you 4x? 2. Multiply 2 times 2x. Multiply 2 times 3. Subtract down. 2 minus 6 is negative 4. So this is your answer. This is your remainder. And you always write your remainder over your divisor. Now you could have put a plus here with a negative if you want. I just decided to put a negative positive 4 over that. Again, you could put positive and negative there. It doesn't matter how you write it. For this particular problem, you're taking f of x and g of x and multiplying them. So you just put this on the top of the box and this on the side of the box. Box is a lot easier for this problem. And then you just multiply the box out, combine terms if you can, start from the highest degree, and work your way down. That's how you do that one. For this last one, if f of x is this, evaluate 4f of x and f of 4. Well, if we had a 4 in front, what that's saying is you're multiplying 4 times this. See right here? 4 times the function, so you multiply 4 in, there's your answer. But if you have f of 4, that's saying put 4 into the function. So f of 4, I'm putting 4 in for the x's. And then I do the math. 4 squared is 16, 2 times 4 is 8, multiply these, combine, negative 40. Okay, so f of 4, oh, by the way, instead of plugging 4 in, you could also use synthetic if you want. This is kind of odd, but you can use synthetic. That would be a negative 3, 2, and 0. And you could use synthetic, and you could get the same answer. Or you just, what it means is to plug it in, but the synthetic does do plugins for you if you want to do it that way. Good luck on the test.